Welcome to this new video number 7 of the Tailwind CSS tutorial series. In the previous video, we started talking about flexbox in Tailwind CSS. Now we will continue with the second part of flexbox in Tailwind CSS. Now we have a new concept, flex grow and flex shrink. To explain flex grow, let's look at the first example. We have two divs inside a parent div with a flex layout. As you can see, the first and second divs have a lot of available space. If we apply flex1 to the first div, it grows to take up more of the remaining space. So when we set flex-1 on the first div, it expands to fill the extra space. This is what we call flex grow. If we also apply flex1 to the second div, both divs share the available space equally. If we add a third div with flex1, the space is divided among all three divs, so each div takes an equal portion. For example, if we remove flex1 from the first div, it keeps its original size, and the remaining space is divided between the second and third divs that have flex1. So that's everything for flex grow. For example, if we have two divs and we set the first div to flex2 and the second div to flex1, the div with the larger flex value, flexnas2, takes more of the available space. In other words, the available space is distributed proportionally based on the flex values. The div with the smaller value gets less space, while the div with the larger value takes more. Now we have another class, flex none. When we apply flex none to a div, it does not grow. For example, in this setup, we have four divs. The first div has flex none, and the other three divs also have flex none. As you can see, the first div keeps its original size, and the remaining space is distributed among the other divs. This is how flex none works. The div does not grow beyond its content or defined width. If we reduce the width of a div with flex none, nothing changes. It always takes its set width. For example, if we remove one of the other divs and keep only two, the div with flex none still keeps its original width. If we increase its width, for example, to W6, it takes that width, and the remaining space is divided among the other divs that have flex 1. Now we move to a new concept, flex auto. Flex auto is a combination of grow and shrink. It allows a div to grow when there is extra space and shrink when space is limited. For example, we have a first div with flex auto and a second div with a fixed width, like W200 or W300. The flex auto div takes up the remaining space. To see the shrinking behavior, we can set the first div's width to W100 and the second div's width to something larger, like W450. As you can see, the first div shrinks to allow the second div to get the width it needs. So flex auto grows when there is extra space and shrinks when other items need more space. Now we move to another property, flex initial. Flex initial can shrink but does not grow. For example, we have a div with a width of 20. If we apply flex initial, it keeps its own width. If we apply flex auto instead, it grows to fill the remaining space. When we switch back to flex initial, the div does not grow, but it can shrink if there isn't enough space. For example, if the second div has a large width like 300, the first div with flex initial shrinks even though its width is set to 40. In contrast, flex auto both grows and shrinks. So the key difference is flex initial shrinks but does not grow, while flex auto does both. Here's a quick summary. Flex auto grows if there is extra space, shrinks if space is limited. Flex initial does not grow but can shrink. Flex none does not grow or shrink, it keeps its fixed size. Now we move to a new topic, ordering items. For example, we have three items, 1, 2, and 3. If we want to rearrange them, we can use the order class followed by a number. For instance, set the second item to order 1, the first item to order 3, the third item to order 2. As you can see, the items are rearranged based on their order values. As shown on the screen, the second div becomes first, the third div becomes second, and the first div moves to the last position. We also have another flexbox concept called self-align. Previously, we learned about justify center, justify start, and item start. Now, we can control the alignment of individual items using the self classes. For example, in this setup, the parent div uses flex and item center. If we want to control the alignment of a specific item, we can apply self-start, self-center, or self-end to that div. Here we keep the first div at its default alignment, and we modify the second div using the self classes to show individual alignment. Let's look at an example. If we apply self-start to the second div, it aligns to the top. If we apply self-end, it aligns to the bottom. If we apply self-center, it aligns vertically at the center. This is the self-align property. It's very useful when you need to control the alignment of a single item inside a Flex container. Now we move to another property, flex basis. For example, we have a parent div containing 3 child divs. Each child div has basis 1/3. This means each div takes 1/3 of the total space. As you can see, the parent space is divided equally among the 3 divs. For example, if we set the first div to basis 2/4 and the second div to basis 1/4, the first div takes half of the parent's width. The remaining half is divided between the second and third divs, each with basis 1/4. So flex basis determines how much space each div initially occupies inside the parent. You can also set flex basis using pixel values. For example, you can use a class like basis value to specify the exact number of pixels you want. That's all for this video. Dear viewers, if you enjoyed it, don't forget to like and subscribe to the channel. Of course, if you have any questions or feedback, feel free to leave them in the comments. See you in the next video.